In this video, I will be answering GCE Chemistry Paper 1, June 2019 session. GCE Chemistry Paper 1, June 2019 session. I'm starting with question number 1. But before I continue, I really want to appreciate those of you who have subscribed to our channel. Those of you who have not subscribed to our channel, please support us by liking the video, sharing, and subscribing to our channel. Do not go without hitting the notification bell. Thank you very much. Thank you for taking your time to subscribe to our channel. Let's start straight away with question number 1. Choose a metal commonly used as overhead electric cable. Choose a metal commonly used as overhead electric cable. We have zinc, we have aluminum, we have iron, and there is copper. It is not copper, it is not iron, it is not zinc, but the metal commonly used as overhead electric cable is aluminum. It's aluminum. So B is right. B is the right answer. Question number 2. Select a method that can be used to separate a mixture of water and petrol. Select a method that can be used to separate a mixture of water and petrol. A. Evaporation to dryness. B. Separating funnel. C. Sublimation. D. Simple distillation. You know that petrol and water are they are immiscible. They are immiscible. For that reason, we cannot use simple distillation. For that reason, we can't use simple distillation. We can use sublimation. The only possible way we can separate a mixture of water and petrol is by using a separating funnel. By using a separating funnel, since petrol floats on water. By using a separating funnel. B is the correct answer. Question number 3. Determine the atomic number of an atom with electronic configuration 2882. Determine the atomic number of an atom with electronic configuration of 2882. The atomic number for this is supposed to be a sum of all this. We have 2 plus this is 10, plus this is 18, plus this is 20. So the answer is D, which is 20. 3 is D. Question number 3 is D. 4. The thermal decomposition of calcium nitrate will produce calcium nitrate and oxygen. It will produce nitrogen dioxide and oxygen. Nitrogen and oxygen. Dinitrogen oxide and oxygen. It will produce this. The compound there is supposed to be nitrogen dioxide and oxygen. Nitrogen dioxide and oxygen, because this is the thermal decomposition. The thermal decomposition of this is this one. The thermal decomposition of calcium nitrate is this one. We will have something like this: calcium nitrate, we'll have something like this to give calcium oxide plus nitrogen dioxide plus oxygen. Balancing the equation, we will have something like we will have 4 nitrogen dioxide. 4 nitrogen dioxide, we will have 2 here. We will have 2 there. And I will also have 2 here. So our product will be nitrogen dioxide and oxygen, and which will be nitrogen dioxide and oxygen, which will be B. Question number 4, the answer is B. We will have nitrogen dioxide and oxygen. B. Question number 5. The transition metal used as a catalyst. The transition metal used as a catalyst in the manufacture of ammonia is A. Vanadium, B. Copper, C. Iron, and D. Platinum. It is finely divided iron. A finely divided iron is the one that is used in the manufacture of ammonia. So C is the right answer. C is the right answer for question number 5. 6. The element X exists naturally as 2 isotopes. The element X exists naturally as 2 isotopes. X has the atomic mass of 80 and 82 in the ratio 1:1. In the ratio 1:1. The relative atomic mass of X will be, calculating the relative atomic mass of X, we have the ratio 1:1 and the relative atomic masses 80 and 82. So what will be done is 80, the 80 of 1, that's the first 80 excuse me, we will have, it will be 80 times 1 plus 82 times 1, their ratio 1:1 divided by 2. Welcome back again. I said the element X exists naturally as two isotopes. The first one with 80 atomic mass of 80, and the second one with atomic mass of 82, in the ratio 1:1. The relative atomic mass of X will be, in this situation, it is 80. It is 80 times 1. 80 times 1 plus 82 times 1. Times 2, sorry. 80. Sorry. Yeah. Sorry. We are told the element exists in the ratio 1:1. So it is 80 times 1 plus 82 times 1. Sum of ratio divided by sum of ratio. Sum of ratio is 1 plus 1 is equals to 2. 1 plus 1. In this case, we will have an atomic number of 81. In this one, we are having an atomic number of 81. So, to calculate this, you need to multiply the atomic mass by its ratio and divide it by sum of ratio. That's what we have just done here, giving us 81. And looking at our column of answers, question number 6, A is the right answer for question number 6. Question number 7. Question number 7 to 9. Question number 7 to 9 concerns the following table. The element M, N, O, P, and Q. Proton, electron have been given. M, N, O, P, and P. M, N, O, P, and Q are not the usual symbol of the element. Each element can be selected once, more than once, more than one, or not at all. Select from the table. Question number 7. An element that will not react easily with other. From the table, you can notice that we have, this is a group 2 element, this is a group, this is group 17 element. N and O are all group 17. P is group 18. So in that case, P is the element that can, an element that will not react easily with other is P. Is P. It's an inert gas or a noble gas. So P is that element. And on our answer column here, question number 7, D is the right answer. D is the right answer for question number 7. Okay, question number 8. Element element that belongs to the same group of the periodic table. Question number 8, element that belong to the same group of the periodic table. Looking carefully, the two elements that belong to the same group of the periodic table is N and O. N and O. They belong to the same group of the periodic table. N and O, and that is D. So D, question number 8, D is the right answer for question number 8. Question number 9. Determine the formula of the compound formed between M and N. M and N. Formula of the compound formed between M and N. M and N is M and N. Going back to our table of the table, N is group 2 and N is group 7. Group 17. Group 2, they have a valency of +2, and group 17, they have a valency of -1. So we have this is one method. We can swap it. It comes here and it comes here, and our result will be M N 2. That is method number 1. And method number 2, we will still have Mn. Another method is we can have M and N. We have a +2 and we have -1. So there's +2 here, there is +2 there, and there is -1 here. This one cannot, if we add this, it can't go. We need to add another -1 again. So now it is +2 and it is -2. So there are 2 of them here, 2 of N, and there is only 1 here. In that case, we will say M. How many of N are there? There are 2 of them, N 2. So that is the formula. The formula is Mn2. The formula is Mn2. Here, question number 9, Mn2 will be what? It's C. Mn2 is C. Okay. Question number 10. Give the formula of the 5th member of the homologous series with general formula CnH2n+2. Okay, this is an alkane. An alkane with the general formula. The 5th member of the alkanes group will be C5. That is C5H12, because there is 5 times 2. 5 times 2 is 10. 10 plus 2 is 12. So our answer here is A. Question number 10, the answer is A. Question number 10, the answer is A. Question number 11. Name 2 air pollutants. Name 2 air pollutants which are responsible for acid rain. Nitrogen and sulfur dioxide. No. There's one sulfur dioxide, not nitrogen. B. Nitrogen and carbon dioxide. There's nitrogen dioxide and carbon dioxide, one but not the other one. C. There is carbon dioxide and there is sulfur dioxide. There is sulfur dioxide, not the other one. D, sulfur dioxide and nitrogen dioxide. D is the right answer. These are air pollutants which are responsible for acid rain. Sulfur dioxide and nitrogen dioxide. D. Question number 12. Question number 12. Which of the following substances will burn with smoky and luminous flame? Remember, only unsaturated hydrocarbons will burn with a smoky and luminous flame. Only unsaturated hydrocarbon. So our answers are A, propane. Propane is not an unsaturated hydrocarbon. B, ethene. Ethene is an unsaturated hydrocarbon. C, hydrogen. D, butane. So B, which is ethene, is the right answer. Ethene is the right answer. Ethene burns with a smoky and a luminous flame. So question number 12, B is the right answer. Question number 13. Calculate the amount of substance in moles. The amount of substance in moles in 250 cm³ of 0.1 molar hydrochloric acid, aqueous hydrochloric acid. Calculate the amount of substance in moles in 250 cm³ of 0.1 molar hydrochloric acid. Okay, it is simple. We have been given the volume of aqueous hydrochloric acid, and we have been given the concentration in molarity, the concentration at 0.1 molar. There is a relation. Concentration, there is a relation which is concentration equals to moles divided by volume in dm³. So concentration, which is equals to moles, concentration equals to moles divided by volume, the volume in dm³. And in this case, we are asked to calculate the amount in moles. So now the number of moles, the moles here will be, rearranging the equation, the number of moles here will be what? Will be concentration times the volume in dm³ times the volume in dm³. And in this situation, the concentration here is what? The concentration here is 0.1. The concentration here is 0.1 times the volume. The volume is 250. In dm³, we need to divide by 1,000. 250 divided by 1,000 would give us 0.25. 0.25. And we multiply this, the number of moles will be 0.1 times 0.25. We will have 0.025 moles. We will have 0.025 moles. And looking at our answer column, we will have C. C will be our answer, 0.025. 0.025 C is our answer for question number 13. Now, let's go to question number 14. Question number 14. When excess carbon dioxide is passed through lime water, the milky color disappears due to the formation of calcium hydrogen carbonate. due to the formation of B. Calcium carbonate, due to the formation of calcium oxide, due to the formation of calcium hydroxide. Remember that when excess of calcium carbonate is passed through lime water, well, lime water will turn milky, but when excess of it passes through it, what happens is that this will disappear and there will be the formation of calcium hydrogen carbonate. There will be the formation of calcium hydrogen carbonate. So A is our answer. A is our answer. Okay, question number 15. What is the color impacted? What is the color impacted to a Bunsen flame by a copper 2 salt? A color impacted to a Bunsen flame by a copper 2 salt. A copper 2 salt, be it a copper 2 ion, a copper 2 salt will give an apple green color. It will give a copper 2 salt will give an apple green color. It will give an apple green color. A copper 2 salt. What is the color impacted to a Bunsen flame by a copper 2 salt? A copper 2 salt will always give a bluish green color, apple green color, golden yellow, brick red color. An apple 2 will give this. It will give apple green color. Copper 2 ion will always give apple green color. It will give an apple green color. All copper 2 ion will give that color. That is what copper 2 ion does. It will give an apple green color. That is what it does. Apple green color. That's what copper 2 would do. But in most instances, when the intensity of the salt, when there is high intensity of the salt, a bluish green color will emanate. When the intensity of the salt is high, a bluish green color will emanate. So for this purpose, based on the question, we will say the color impacted to a Bunsen flame by a copper 2 salt will be a bluish green. It will be a bluish green. So the answer is a bluish green. The answer is a bluish green, since it is only copper 2 salt. Copper 2 salt is a bluish green. Okay, question number 16. Question number 16. The apparatus used in preparing a standard solution is a burette, a measuring cylinder, a pipette, a volumetry flask. Of course, the volumetry flask is the apparatus that is used as a standard for the preparation of a standard solution. it is labeled 1000 ml or 1000 cubic centimeters. So D is the right answer. A volumetry flask for question number 16. Question number 17. Question number 17. During an oxidation reaction, an oxidizing agent will gain oxygen. An oxidizing agent will loses oxygen. Oxidizing agent loses hydrogen. Oxidizing agent loses electron. Remember that oxidation is loss of electron. Oxidation is loss of electron. Oxidizing agent is gain of electron or hydrogen. Oxidation is loss of electron. Oxidizing agent is gain of electron or gain of hydrogen. In other words, loss of oxygen. Oxidation is addition of oxygen to a compound. Addition of oxygen to a compound. Oxidizing agent is loss of oxygen. So in this case, we said during an oxidation reaction, an oxidizing agent will do what? An oxidizing agent will lose oxygen. It will lose oxygen. So B is the right answer. It will lose oxygen. Loss of oxygen or gain of electron. Loss of oxygen or gain of electron. So it is B. Question number 17 is B. Question number 18. Question number 18. Question number 18. Calculate the quantity of electricity in Coulomb if a current of 0.5 A is passed through an electrolyte for 15 minutes. Well, we'll come to that. Let's go to question number 19. We'll come to that. Question number 19. The number of replaceable hydrogen atoms in a molecule of an acid is called its acidity, alkalinity, basicity, the pH. You know, you can define an acid. You can define an acid as a proton donor. You can define an acid as a proton donor. And this proton, we are referring to the number of hydrogen atoms in that molecule. So, as the question reads, the number of replaceable hydrogen atoms in a molecule of an acid is called its acidity. So A is the right answer. A is the right answer for our question number 19. pH. So it's the same thing. We can calculate the hydrogen we can calculate the pH from the hydrogen ion concentration. So the number of replaceable hydrogen atoms in a molecule of an acid is called acidity. So A is the right answer. Number 20. The substance left in the glass. The substance left in the glass when excess dry hydrogen is passed over heated copper 2 oxide. When excess dry hydrogen is passed over heated copper 2 oxide, what would be the substance? Well, we need to write the equation before we can determine. We need to write the equation before we can determine what is left. Let's say copper 2 oxide, copper 2 oxide plus a hydrogen, What is left there? What is it is copper. It's copper 2 oxide plus hydrogen. We will have copper solid. We will have copper, and that will be solid, and plus water. That is water. So the substance left from the question, the substance left in the glass tube when excess dry hydrogen is passed over heated copper 2 oxide, the substance will be what? Will be metallic copper based on our reaction equation. It will be metallic copper. So D is our right answer. Let's go to question number 22. Question number 21. The function of limestone in the extraction of iron is to remove excess air, is to remove earthy impurities, is to remove unburnt coke, is to remove molten iron. Remember, during the process of the extraction of iron, limestone is used. Limestone is used to remove impurities, especially silicate impurities. It is used to remove impurities, silicate impurities, silicon dioxide. So in that case, earthy impurities is the right answer. So B is our right answer. Question number 22 to 23. Instructions. Each question is followed by 4 responses numbered 1 to 4. One or more of these responses is or are correct. Decide which response or responses are correct, then choose. If it is A, if only 1, 2, and 3 are correct. B, if only 1 and 3 are correct. C, if only 2 and 4 are correct. D, if only 4 is correct. Okay, question number 22. Question number 22. The factors that influence the preferential discharge of ions. Preferential discharge of ions during electrolysis are 1. The position of the ion on the electrochemical series. Yes. The nature of the electrode, yes. The concentration of the ion, yes. And number 4, the discharge on the ion, no. So there are 3 factors. I know the position of the ion on the electrochemical series is one of the factors. I know the nature of the electrode. It must be an active electrode, whether it's active or inactive. I know the concentration of the ion. So we have 1, 2, and 3 are correct. And if I go to my answer column, question 1, 2, and 3 is A. So question number 22, A is the right answer. Question number 22. Question number 22, A is the right answer. A is the right answer. Okay. Question number 23. A catalyst is a substance. A catalyst is a substance which increases the temperature of a reaction. Not acceptable. A catalyst is a substance which increases the rate of a chemical reaction. Acceptable. A catalyst is a substance which increases the yield of a chemical reaction. Not acceptable. A catalyst is a substance which remains chemically unchanged at the end of a reaction. Acceptable. Yeah. A catalyst will increase the rate of a reaction by lowering the activation energy. That one, we know it very well. So, looking at the answer column, I have only answer 2 that increase the rate of chemical reaction, and 4. 2 and 4 are the right answers. 2 and 4. And if I go to the column, I will have C as my right answer. Question number 23 is C. C is the right answer. Question number 23, C is the right answer. Question number 24. Question number 24. The component of crude oil can be separated by A. Reforming, B. Cracking, C. Simple distillation, D. Fractional distillation. Of course, we cannot separate it by reforming or by cracking or by simple distillation. The only way we can separate crude oil is by fractional distillation, because they are arranged in because of the different components in there have different temperatures. They have different temperatures, and the fractional distillation is arranged in such a way that the different components are separated based on the temperature of the component. So it is a fractional distillation, which is a D. D is the right answer for question number 24. D is the right answer for question number 24. Question number 25. The empirical formula of an organic compound is CH. If the relative molecular mass of the compound is 78, then the molecular formula is okay. We have been given the molecular formula. We have been given the molecular formula of the relative molecular formula and the empirical formula. CH is CH. By calculating it, we will have CH. CH is equals to 78. And CH, this C is 12 plus this is 13. 13N, yeah, that is 30, yeah, which is CH, yeah, I will do it as 13N. 13N is equals to 78. And what should be the value of n? N should be 6. And if we substitute n into this equation, into this empirical formula here, we will have C6 and H. We will have C6 and H what? H6, implying that we will be having benzene. We will be having benzene as our formula. So it will be C6H6. So B is the right answer. B is the right answer, C6H6, for question number 25. Okay, let's go to question number 26. Carbon dioxide is prepared in the laboratory by the action of dilute hydrochloric acid on the marble chips. Dilute sulfuric acid is not suitable for this process because 1. An insoluble coat of calcium sulfate will be formed, causing the reaction to stop. B. The reaction will be too fast. C. The reaction will be too slow. D. Marble chip do not react with dilute sulfuric acid. You know, in this case, excuse me, calcium sulfate is formed during the reaction. And it is insoluble in water. So when dilute sulfuric acid is added there, calcium sulfate is formed during the reaction, and it is insoluble in water, and will cover the marble chips, causing the reaction to stop. So going to our answers, an insoluble coat of calcium sulfate will be formed, causing the reaction to stop. So in that case, our answer for question number 26 is A. Our answer for 26 is A. So 26A is the right answer. Now question number 27, select a carbonate that will not decompose when strongly heated in an open crucible. Select a carbonate that will not decompose when strongly heated in an open crucible. There is calcium carbonate, there is copper carbonate, there is sodium carbonate, there is magnesium carbonate. Which of these will not decompose? It will not be calcium carbonate, it won't be copper carbonate, it won't be a group 2, it is only a group 1. Group 1 carbonate, and that is a group 1 carbonate in this case is sodium carbonate. A group 1 carbonate will not decompose. So our answer is C. Now question number 28 to 30 concerns the following substances: ammonia, lemon juice, water, and ethanol. Each letter can be used once, more than once, or not at all. Select from A to D. A to D, a substance. Select from A to D a substance which produces steamy fumes with phosphorus pentachloride. Steamy fumes with phosphorus pentachloride. This is a test. This is usually a test that is used as a test for alcohol. The production of steamy fumes with phosphorus pentachloride is usually used as a test for alcohols. So in selecting it, it says select a substance which produces steamy fumes with phosphorus pentachloride. I say it is used as a test for alcohols. So in that case, D, ethanol will produce steamy fumes when reacted with phosphorus pentachloride, and that is used as a test for alcohol. So D, which is ethanol, is the right answer. So here 28 is D. 28 is D. 29. Select from A to D a substance that will turn moist red litmus paper blue. It will turn moist red litmus paper blue. What will turn litmus paper blue will only be an alkaline substance. So in that case, we will call ammonia gas. Ammonia gas, that is A. That is the only one that will turn moist red litmus paper blue. So we have A. A will do that for 29. Ammonia gas will do that. Now let's go to question number 30. Select a substance A to D that will turn blue litmus paper red. Okay, that's question number 30. Anything here which is acidic that will turn blue litmus paper red must be acidic. It is not ethanol, it is not water, it is not ammonia. It must be a lemon juice. Lemon juice are acidic. So that is what they will do. So it is B. B will do that. B will do that. B is lemon juice and it will turn that. It will do that. It is B. The answer is B. Lemon juice. Okay, question number 31. Question number 31. Determine the percentage by mass of nitrogen in ammonium nitrate. Ammonium nitrate. Given the relative molecular mass of ammonium nitrate as 80. In order to determine the percentage by mass of nitrogen, what you will do is nitrogen. What is the mass of nitrogen? Nitrogen is nitrogen from here is 14. Nitrogen is 14, and it will be 14. It will be 14. What is the relative molecular mass over the MR of times 100? And what will be our result? Our result will be 17.5%. 17.5% nitrogen. So if we go back to our 17.5% nitrogen, if we go back to our answer column, we will say that A is the right answer. A is the right answer for this question. Now, question number 32. Which of these halogens is the most reactive? Which of these halogens is the most reactive? Reactivity of halogen will decrease. Reactivity of halogen decreases down the group. Reactivity of halogens decreases down the group. Unlike in metals, their reactivity increases down the group. So with halogens, we have A, which is chlorine, B, which is bromine, and C, which is iodine, and D, which is fluorine. Fluorine is the most reactive. So our answer is D. (32) is D. 32 is D. 32 is D. Now we're going to 33. We're going to 33. Which of the following occurs during electrolysis of aqueous copper 2 sulfate using copper electrodes. Using copper electrodes. If we are using copper electrode and we are also using copper, know that at the anode and under the cathode, at the anode or the anode and the cathode are full of the copper electrodes. So in this situation, for copper 2 sulfate, aqueous copper 2 sulfate, copper 2 sulfate, the OH will have no use at the anode. The OH will have no use there. The OH will have no use at the anode and the sulfate, because the copper itself will break. Remember that active copper anode breaks. It will break and will be deposited at the cathode again. Everything will go back to the cathode. Everything will go back to the cathode. But let's go to the answer. Okay. Which of the following occurs during the electrolysis of aqueous copper 2 sulfate using copper electrode? A. The cathode increases in size. B. The anode increases in size. C. The color of the solution fades. D. Oxygen is discharged at the anode. As we said, nothing is going to happen at the anode because the OH will not go there, the sulfate will not go there. So in that case, the active copper anode will break and will be deposited at the cathode. All the cations will move to the cathode, and at the cathode, that is where they will be deposited. That's where they will be deposited. And in that case, the cathode is going to increase in size. So our answer will only be A. Our answer will only be A. Our answer will only be A. Nothing is going to happen at the anode. So the cathode will increase in size. Okay, question number 34. Question number 34 will be: the compound most likely to be present in a bag of fertilizer. The compound most likely to be present in a bag of fertilizer is we have four components here, four answers: calcium nitrate, ammonium phosphate, ammonium chloride, and sodium chloride. Yeah, most of the fertilizers today are NPK fertilizers containing nitrogen, phosphorus, and potassium. But here we have only two major ones that are there: ammonium, which is providing the nitrogen, and phosphate, which is also providing the phosphorus. So in that case, the compound most likely to be present in a bag of fertilizer is B. Our answer for 34 is B. Okay. For question number 35, question number 35 to 37, because of time limitation, we will go straight away to question number 38. Question number 38. We'll go straight away to question number 38 because of time limitation. Question number 38. Palm wine goes sour. Palm wine goes sour when exposed to air for some days, because A, glucose is converted to gluconic acid. B, ethanol is converted to ethanoic acid. C. Glucose is converted to ethanol. D. Palm wine is converted to palmitic acid. Of course, palm wine contains glucose. For the purpose of revision, palm wine contains glucose. And this glucose, inside there is what we call yeast. And if exposed to air, there's going to be what we call aerobic respiration. There's going to be fermentation. Sorry, there's going to be fermentation. There's going to be fermentation that's going to take place if exposed to air. And in this fermentation, for the purpose of revision, glucose is converted to ethanol. Glucose is converted to ethanol and carbon dioxide. And if you were using a test tube or using a conical flask, you have a bit of lime water. You will test the gas that is being produced to be sure whether the carbon dioxide is one of the products of the fermentation of glucose. So it should be recalled that glucose is converted to ethanol. And let me just write the equation. Glucose is converted to ethanol. We have C6. Glucose is C6. H12. O6. This is aqueous. It is converted to aqueous plus carbon dioxide, the gas that is being released. So in that case, you can test it. You can test it. I said there's yeast. The catalyst here is a yeast. So I said palm wine has yeast in it that will accelerate. It's a catalyst. It will accelerate the process of fermentation into alcohol. And if you have lime water, you can still test the gas that is being released, whether it is carbon dioxide. So in that case, we go back to our answer column. You will see that our answer for this is C. Glucose is converted to ethanol. Is C. That is be our answer. Now, question number 39. Question number 39. Calculate the mass of zinc that will produce 16 grams of copper. That will produce 16 grams of copper, according to the equation zinc solid plus copper sulfate copper sulfate to give zinc sulfate plus copper. Okay, you need to calculate the mass. You have been given the mass of copper. You will use that mass to calculate. You will use that mass to calculate the moles. You will use that mass to calculate the moles. Okay, from the equation we have zinc, zinc solid plus copper sulfate aqueous to give zinc sulfate, which is still aqueous, plus copper solid. Then we have been told calculate the mass. In this case, we are dealing only with this. We are dealing only with this one. So here, you can say 16 gram of copper. 16 gram of copper is equivalent to how many moles of copper? The relative atomic mass of copper is 64. 16 grams of copper is equals to 0.25. 0.25 moles. 16 grams of copper is equal to 0.65 moles. Okay, you can say if one mole of copper, zinc, sorry. If one mole zinc, if 1 mole of zinc from the equation, if 1 mole of zinc can give us 1 mole of copper, can give us 1 mole. If 1 mole of zinc can give us 1 mole of copper, then how many moles of zinc? How many moles of zinc? Moles of zinc will give how many grams? We were given 16 grams of copper. We give 16 grams of copper, or 0.25 moles of copper. We have converted the number of moles of copper into the number of grams into we have converted that into the number of moles. So there's no big deal there. So now what we will have will still be what? We will still have 0.25 moles of zinc. 0.25 moles of zinc. But the mass, we know that moles is equal to what? Mass all over relative atomic mass. In that case, the mass will be what? The mass will be what? Moles times what? The relative atomic mass. And the mass of zinc is what? The moles of zinc is what? 0.25 times what is the relative atomic mass of zinc? The relative atomic mass of zinc is 65. The relative atomic mass of zinc is 65. So now if we multiply this, we will have 16.25 gram of what? Of zinc. We'll do that. So now if we do 16.25 zinc, we'll go to our answer column. Our answer column there, 16.25, we will have our answer here will be C. 39 will be C. .25. Question number 39 is 16.25, which is C. Now, question number 40. Which of the following is a basic oxide? The basic oxide here is an oxide of a metal. An oxide of a metal, especially group 1 metal. And the basic oxide here is sodium oxide, which is C. Question number 41. Question number 41. What is the mass of 0.1 mole of sodium carbonate? Sodium carbonate. Relative molecular mass of sodium carbonate is 106. The mass of this will be just to multiply the mass will be what? The mass here will be moles times the relative relative molecular mass, which is what? 0.1 times 0.1 times what? 106. And that is what? 0.1 times 106. 0.1 times 106. The 106 drop here, which is D, is 10.6. 10.6. So our answer for 41 is D. Our answer for 41 is D. Question number 42. Question number 42. Plastic pollute the environment because they are insoluble in water. They are non-biodegradable. They are biodegradable. They are inflammable. So the only thing plastic do into our environment is that they cannot degrade. For that purpose, we say they are non-biodegradable. B is our right answer for 42. Question number 43. The different components of the universal indicator solution can best, excuse me, the different components of a universal indicator solution can best be separated by a fractional distillation, filtration, chromatography, simple distillation. Once more, learners, I will ask you to go and watch our previous video on the separation or experimental techniques. Separation and experimental techniques, especially on paper chromatography. Go watch our previous video on separation techniques or experimental techniques. Especially on paper chromatography, you will have more knowledge on these different, you have more knowledge on the different techniques in techniques in separation. So the answer here for this, since this has colors, what we will do will be, we will use but a paper chromatography. Here it is chromatography. So our answer here is C. Our answer here is C. 43, our answer is C. For 44, for question number 44, consider the reaction sodium hydroxide plus hydrochloric acid. We will have sodium chloride and water. This is a neutralization reaction. You have been given delta X. You have been given delta HX, kilojoule per mole. Delta HX kilojoule. Now, what does X represent? Remember, I said this is a neutralization reaction. And the X, if we were to measure the enthalpy change, we will be measuring by the enthalpy change of neutralization. We will not be measuring the enthalpy change of activation. We will not be measuring the enthalpy change of formation. We will not be measuring the enthalpy change of solution. We will be measuring by the enthalpy change of neutralization. So X is enthalpy of neutralization, or what we call heat of neutralization. So A is the right answer. A is the right answer. Is heat of neutralization. Heat of neutralization or enthalpy of neutralization. Enthalpy change of neutralization. So let's go to question number 45. 0.1, question number 45. Is heat of neutralization. Okay. Now, 45, 0.1 molar hydrochloric acid reacts with powdered sodium chloride. According to the equation, 2 moles of hydrochloric acid equals plus 1 mole of sodium carbonate to give sodium chloride plus water and carbon dioxide. How can the reaction be made to go faster? You are given A, 0.5, using 0.5 molar hydrochloric acid, using lumps of sodium carbonate by adding water to the reaction and by using 0.01 molar hydrochloric acid. The only way is by increasing the concentration of hydrochloric acid, and the only increased concentration here is using 0.5 molar hydrochloric acid. 0.5 molar hydrochloric acid. So A is the right answer for 45. A is the right answer. A is the right answer for 45. Now, let's go to question number 46. Now, how many particles of sodium hydroxide are contained in 0.1 mole of sodium hydroxide? We have been given the Avogadro constant or the Avogadro number. Now we have been asked to calculate the number of particles there. Remember that Avogadro constant, that is Avogadro constant, that is when 1 mole of a substance, when 1 mole of a substance contains those number of particles. So in Avogadro constant, 6.02 times 10 to the 23rd power is for 1 mole of any substance that may contain electrons, atoms, molecules, or ions. So if 1 mole of a substance contains those number of particles, if 1 mole of a substance contains those number of particles, then 0.1 mole of sodium hydroxide will contain what? In other words, if 1 mole of sodium hydroxide, let me say if 1 mole of sodium hydroxide, 1 mole of sodium hydroxide contain 6.02 times 10 to the 23rd particles. Then 0.1 mole of sodium hydroxide will contain what? It will contain X, and the X will be what? X will be equals to 0.1 times 6.02 times 10 to the 23rd particles. And if we multiply this is 1 decimal place, so 1 decimal place this other side, and it reduces it will be 6.02 times 10 to the 22nd particles. So this will be the number of particles for 0.1 mole of sodium hydroxide. 6.02 times 10 to the 22nd. So if we check in our answer column, we will have our answer there for 46 will be 6.02 times 10 to the 22, which will be D. D will be our answer. Then question number 47 to 48 are based on the diagram below. We have a diagram there showing a dish, salt solution, steam, and boiling water, and gas and heat. The question 47. One method of separation is illustrated in the diagram above. It cannot be sublimation, it cannot be evaporation to dryness, it cannot be filtration. This method, the only method you can do here in the lab for the preparation of salt, of crystals, is crystallization. This method is used for the preparation of crystals, and it is crystallization. So 47 is A. 47 is A. 48. An example of a mixture. An example of a mixture that can be separated by this method is kerosene and water. No. Ethanol and water. No. Ammonium chloride and sodium chloride. No. D. Sodium chloride and water. D is the right answer that you can use in separating this. separating water and salt. So D is the right answer. That is the right answer for it. Now, question number 49. Question number 49. Select the process that involves a physical change. 1. Corrosion. Corrosion is not a physical change, it's a chemical change. Corrosion is a physical, it's rusting. Corrosion is rusting. Reaction of iron and oxygen. That's rusting. That is a chemical change. And C. Burning a piece of sodium. Burning a piece of sodium involves a reaction of sodium and oxygen. So no, it does not involve a physical change, but a chemical change. Electrolyzing dilute sodium chloride. Electrolyzing it will lead into the formation of ions. They are still in the liquid form. They are ions. They are still in the liquid form, but we have not changed the physical state. It is electrolyzing dilute sodium chloride. We have not changed the state because they are still in the liquid form. They are ions. They are just ions now. Then heating candle wax. Heating of a candle wax will lead a solid to a liquid. When candle burns, it changes in state from the solid to the liquid state. And in that case, there is a change in physical, there is a physical change. So A is our right answer. And question number 50, the last question. Isotopes of a given element have the same mass number of neutrons, the same properties, the same atomic number. Remember, what are isotopes? Isotopes, these are atoms of the same element having the same proton number or the same atomic number, but different mass numbers as a result of due to the different number of neutrons. They will have different mass numbers as a result of different number of neutrons. So our answer here will be the same atomic number. D is our right answer. D is the right answer for 50. Thank you, learners, for being patient. Thank you. Wishing you all the best in your exams. Thank you very much. Once more, if you haven't subscribed to our channel, please don't forget to subscribe. Support us by subscribing to our channel, liking our video, and sharing to other fellow learners. Thank you for taking your time to watch our video. I wish you best of luck in your exams.